Now, hello, welcome. Welcome to today's panel discussion on performance modeling in early design phase. Today's panel discussion is organized by IBPSA-USA's Education Committee. IBPSA-USA has multiple committees. You can check them out on their website, and you're welcome to join any of the committees you find interesting. IBPSA-USA has ample of resources like Ask a Modeler or Unmet Load Hours, and we organize multiple webinars. These are free for everyone to watch and learn. We hope that it encourages our peers to share knowledge and resources so that we can move together as an industry. If you aren't a member already, it's very easy to sign up on the website. And with that, hello, my name is Apurva Pradhan and I'll be your moderator for today. Before I begin, I just want to go over some housekeeping items. This webinar is being recorded and the recordings will be available to watch on YouTube as well as IBPSA USA's website. We have a Q&A session for the latter part of the panel discussion, but feel free to drop your questions in Q&A box and our panelists will try to answer them in real time. With that being said, allow me to welcome our three wonderful panelists, Dan Stine, Melissa Kelly, and Brett Horin. Oops, yes. So Dan is the director of design technology and leads the internal research program investigation at a top rank architecture firm called Flato in San Antonio, Texas. He's a registered architect, educator, author, blogger, and an international speaker. Our second panelist is Melissa. She is a senior sustainability specialist at Gensler in New York. She supports informed decision-making through data analysts and performance simulation, quantifying relationships between building and energy, daylight, urban microclimates, water and food balance, and renewable energy feasibility. Our third panelist is Brett. He is a high-performance building analyst at CannonDesign. Brett has experience with whole building energy modeling, energy master planning, CFD analysis, daylight simulations, and life cycle assessment. Working with project teams, Brett aims to simplify technical content with insightful data visualization to impact design decisions. Welcome, all three of you. It's a pleasure that you are a part of this panel discussion. And with that, I hand it over to Melissa to begin her presentation.
Great, thank you so much. So hi everyone, I'm Melissa. I work at Gensler in the sustainability consulting role. And today I'd like to talk a little bit about some of the approaches which are less on the technical side, because I think performance modeling during the early stages of design, we often have the right tools, but the real challenge that we face is in the delivery and in the perceived value of this type of work. And so I'm more or less an energy model who is undercover at a design firm, and I've learned a lot of really interesting things about what has been helpful in terms of making early work successful and engaging for our project teams. So Gensler, we are quite a large design firm. We have 53 offices globally. We have over 7,000 employees now and over 4,000 clients. And that means we do a little bit of everything from urban planning to even brand design and innovation consulting. So it's a really fun place, very dynamic, and lots of unique problems that we have to try and solve. With that scale, our work is really diverse. And we organize ourselves into 29 different practice areas across basically by project type. So each of these practice areas has a dedicated sustainability champion. And we also have sustainability champions at the regional office and studio levels. So we try to integrate sustainability as much as possible throughout our firm. But we also have a dedicated practice area called Climate Action and Sustainability, which houses all of our experts that are focused specifically on the delivery of high performance projects and scalable solutions that will help us to slow climate change. And in that practice area, we really mix and match strategy, analytics, and certification to deliver effective change on our projects. So we're often doing 2 or 3 of these. Very rarely do we do analytics just as standalone work. It's always about how do we focus that in the context of the larger project and the sustainability goals of that specific work and that client as well. And all of this is part of our firm-wide commitment, which is the Gensler Cities Climate Challenge, which is our pledge to target net zero carbon across all of our projects. So every project, every location, every person. And so that's a lot. It's very daunting. And we have to be really strategic about the way that we engage our projects to make this work. So our analytics practice, we focus on early interventions. So we're typically involved in the projects from pre-concept through DD. And that's when, as we all know, there's a really great elasticity for improvement and simple changes that can have a huge outcome later on in the performance of the project. The other thing that we really try to do is take an integrative approach to our work. So we're always thinking about co-benefits. We're often layering these simulation lenses on top of each other. So we're very rarely looking at just energy or just daylight. We're looking at all of this together and thinking about it in terms of environmental impact and human experience. And one thing that's really been helpful and that we try to make a foundational part of our approach is that this idea that to get a useful answer, you really need to ask a useful question. So we have these really large firm-wide goals that we're trying to solve across our portfolio. And for individual projects and project teams, that feels really daunting. So what we found that's really helpful is to frame it in terms of these specific questions. And that is helpful in sparking curiosity and understanding how these types of tools are really helping you to solve design problems and can start to develop connections to foundational project goals. So sustainability is not something that's just off on the side that you can right away. And because of our scale and the need to work across all of these different performance lenses, we have a lot of software options. Typically, we're always trying to consider how our work might need to evolve from one platform to another over the course of pre-design through concept and DD. We also often work with multiple programs in parallel. So for that reason, on the tool side, we tend to favor those that work really well with our existing geometry and BIM platforms, so we can kind of keep up with design changes, but also that work well with each other or that work with parametric tools like Grasshopper and Dynamo, so we can connect them together and keep everything moving dynamically. And one thing that's also been really interesting to me transitioning from a more of a compliance modeler to someone now focused on early stages of design is the way that I approach work. And it becomes very different. And so over the course of the past couple of years, I've developed these different 3 types of engagements that have been really successful integrating with our design process. First, we've got a classic, design charrettes and workshops as early as possible. And we're bringing to the table all of the analytics data that we can, shoebox models, climate assessments, and other kinds of early stage analysis. And we're using that as a starting off point to understand the project's goals and specific challenges and constraints that might help them later on down the line, just to keep it in mind. Second, we have this iterative approach, which I call the question of the week model. And there we're doing a series of focus studies where each week we have one particular item that we want to solve. And the goal overall is to provide directional guidance. So those studies are a mechanism by which we can constantly keep checking in on the sustainability goals as the design develops. And third, we also do provide more detailed client-facing services, long-term engagements on our projects. We do research projects where we're developing new methodologies. So for that type of work, we're always thinking about how can we scale it or create some kind of replicable methodology that we can use for them later on. Projects which are a little bit more constrained can still learn from that process and grow on that process. So I'm going to go through a very quick example of how each of these 3 models play out. The first one on this slide, so this is the design workshop approach. It was for a large mixed-use development. And for this study, we had a big workshop with the client and the whole project team. And we wanted to understand first where within the program on the site should we really be focusing our efforts to have the most impact? And then also, what is it going to look like to target different levels of performance? So we developed a shoebox model, which we used to create this sort of general EUI breakdown. And a lot of that information was from more detailed studies that we were kind of applying to this new location. And then we ran a series of bundles of energy conservation measures, ECMs on top of that. And even if those bundles aren't really the final design, at least it gave the team a conversation ability to make things more tangible and talk through what 10% savings versus 25% savings is going to look like on the actual building. And we also do a lot of interiors work at Gensler. So for those projects, we found it's really successful to start with a floor plate daylight assessment. And this is a really fun study. It serves the same function as a site analysis for a building, and really similar to how you're thinking about early massing decisions. On the interior side, you can also think about early programmatic requirements. So how do you lay your space out to take advantage of daylight and sunlight and so on? And that's really hard for people to intuit, especially in dense urban environments. So this is information that when the team gets it early in the design, they're really equipped and empowered to make those decisions and talk about it more tangibly with their client. This is an example of a question of the week project. So this one was also really fun. We co-developed all these studies with the design team, and each week we were kind of reacting to the results of the week before and building on that progressively. So it also really followed ASHRAE 209, which is one of my favorite ASHRAE standards, and it works from larger to smaller design moves as we progress more and more detail into the model. So the first study that we did was a massing comparison, pretty straightforward. All the different options on the table, we used that as a comparison to understand what was working well and what wasn't, and ultimately refine a massing shape that was a little bit of a combination of everything that was successful. So we had some berming in there. We also had a roof that was tilted more towards the north and sloped towards the south. In the second study, we looked a little bit more closely at the effects of that roof shape, thinking about it in terms of daylight instead of energy now. And we noticed that the daylight zone on the north was much larger than that on the south because of this extra space that the roof was providing us for glazing. So we found that basically having the center core there was really creating a problem in terms of getting that daylight and maximizing it. So we used this to identify where the best space for the core was, talk through it with the client, and get more and more daylight there. And then once that was set, we kind of noticed that something funny was going on the south. So we started to think about shading, because we noticed that the reason that we had almost no daylight on that side, because in the simulation, of course, the shades are coming down a lot. And lastly, this is an example of a standalone research project with multi-attribute analysis. So this is something where we were really able to go deep, go all out in terms of what we were putting together, and then use that thoughtfully for future projects too, as a way to create new workflows and use that, basically reuse the information and the workflow that we have. So we did this in Grasshopper with some honeybee components and custom components, and we were looking at future conditions right after New York City announced the upcoming carbon limits for commercial buildings. So this was announced 2019 or 2020, I already can't remember. It's coming into effect next year. So we used that kind of big picture thing that everyone was talking about as a starting point to launch this deeper investigation into how to project sensitivity to future climate conditions and legislative conditions. And here we're thinking about these are emissions, but we also looked at energy costs, peak heating and cooling loads, and thermal comfort. And we could use this entire workflow later on, so we can replicate it or we can modify it on projects. We can use some of the resources that are available. So one of the challenges that I think was exciting about this, and what I'm really looking forward to tackling as we get even more ambitious with our goals, is how to create these types of feedback loops between projects and continue to build each one on each other. So we're just kind of spreading the message that everyone can at least do something. We can all learn from each other. We can all build on each step ahead and make progress together. So yeah, that's what's going on at Gensler right now for performance analytics. There's lots more to come. I think we've really got our work cut out for us in terms of trying to get to our decarbonization goals. But thank you all for listening, and I'm really looking forward to hearing the questions and discussing more with Brett and Dan about their great approaches as well.
Thank you so much, Melissa, for a wonderful presentation. Let's move on to Brett.
Okay, can everyone see my screen?
Yes.
Okay, perfect, thank you. So hi everyone, I'm Brett Horin. I'm a high performance building analyst at CannonDesign. My background is in architecture and engineering, specifically focusing on simulation work and energy modeling within the AEC industry. I would say I view simulations as a means of testing systems at vastly different scales. So whether that's thermal modeling of a curtain wall mullion or doing daylighting studies of a whole floor plate, all the way to campus-wide energy master planning, simulations should really be used as a tool to help design teams make decisions. And so that's what I strive to do at Cannon. And so now I'll talk about Cannon a little bit, some background about the firm, some facts, and a little bit about our design approach. So we have a living centered design approach where, whether it's sustainability, equity, or human health, we're striving to make an impact with holistic design to just better improve all aspects of our buildings. So we have about 1,100 employees across the US and Canada, as well as an office in Mumbai, India. And we also have an in-house firm-wide sustainability team. And that team that I'm a part of helps with all the sustainability coordination for our projects. And then we have a subgroup that I'm in called the Environmental Performance Lab. And so a few of us within that group are our in-house energy modelers and simulation experts to help teams achieve their sustainability goals through the use of exploratory simulation work. And then just a few facts about Cannon. So we have been reporting our energy metrics to the AIA 2030 commitment for the last 12 years and counting, made possible by the fact that we have an in-house sustainability team. And then also a couple of other notable facts. In 2021, we were named the #2 most innovative company in North America by Fast Company. And then last year in 2022, on the Building Design and Construction Giants 400 report, we were ranked #2 in the healthcare sector for architecture and AE firms. And so largely our project work does focus around the healthcare sector and then also with higher education, just to name a couple. And now I'll quickly show a couple of projects from that are either finished or have some renderings, just to show kind of where we're integrating sustainability into some notable projects. So the first one on the top two pictures are the Ohlone Community College, which features net zero design and some LEED Platinum buildings. Then in the bottom left, we have Kaiser Permanente's Radiation Oncology Center, which achieved LEED Gold. And then in the bottom right, we have Caltech's Resnick Sustainability Center, which features a mass timber design curtain wall system. And so these are all projects that, looking at these photographs and renderings, we've been able to implement and bring some of our sustainability features to fruition. And so now I'm going to go through our process, especially early in design, that helps us to get to this point of implementing them on the projects. So in talking about the elements of early design phase modeling, I'm going to break this into 3 different buckets just to try to simplify it. So the first is going to be benchmarking. The next will be single aspect simulations. And then the last will be whole building energy modeling. So with benchmarking, what I find is that it's an important first step to understand the ballpark of energy usage for your project, given the building type or the climate. And it's a really important insight phase where, without doing any modeling, we kind of get a sense of what we might be looking at for this project. Then as we move into single aspect simulations, that's where we're looking at individual metrics like daylighting, heating and cooling loads, thermal comfort, and really analyzing those on a one-off basis just to see where and how we can implement certain passive design strategies. And then as the project develops, gets into SD and DDs, we can start to look at a whole building energy model. And that's where we can really start to test the different passive and maybe active strategies that we've been thinking about for the project and see how they affect the energy usage and carry that through to the final certification and code compliance models. So I'll just go through one example of each of these Buckets. So first, talking about benchmarking, I wanted to talk about this in the context of a presentation that my colleague Amir Razai and I did at Simbuild this past year. We developed a dashboard that we called the Rapid Energy Design Tool. And really what we did here was combine historical CVEX data with an ASHRAE energy modeling study, RP 1651, in hopes of using this open source data to provide helpful benchmarking insights for projects really at the beginning of design, no modeling necessary, just using information that's readily available to get insightful benchmarking information. So when we look at the sample dashboard that's up here, for example, this is looking at a hospital in, let's say, Chicago, that's between 200,000 and 500,000 square feet. Just by entering that information, we're able to pull from the CVEX data to figure out what a benchmark EOI might look like for a typical building of that type and climate. And the CVEX data is readily available from their website, but then it's used in Zero Tool, which is a very popular website that people use, especially for the AIA 2030 commitment. Then the next EOIs that we're looking at are then pulling from this ASHRAE report. So looking at the energy model data to look at what the feasible, basically a feasible EOI that you can get with a code building, but then as well as getting to the lowest technical feasible EOI in order to achieve a net zero design. So in this case, a hospital with a benchmark EOI of 270, then a typical code might be 128, and then the lowest technical feasible, given all the base loads that you have to consider, might be an EOI of around 70. And so then from there, what amount of PV would we necessarily need to, or what would be the minimum amount of PV in order to achieve a net zero design with this type of project? And then from there, also from that ASHRAE study, we're able to look at the top strategies that might have the biggest impact given this project type and climate. And so all this is done just using some input information and looking at open source data. So no modeling involved, just to really provide a powerful insight to a project at the beginning. So then once we've done our benchmarking, then we can get into the single aspect simulations approach. And so this is just a sandbox project, not a real project, just to showcase kind of the workflow that we can go through in looking at some of these single aspect simulations. So this, let's just say it's a sandbox building, 200,000 square foot, 18-story office building in Chicago. What are the different, massings and orientations for this building that can achieve optimal metrics that we're looking at? And so here we're looking at site daylight, interior daylighting, and then solar gains in the winter and summer. The reason why I'm pulling this up and trying to showcase this in this way is because a lot of the times we might have teams that are asking, what's the best design that we can do? Just blanket question, which is obviously there are many answers to that. And so the answer that I always say is that it depends, because there are so many different variables. And then also depends on what metrics you're prioritizing, which is very important to consider with a holistic design approach. So if we look at all these results between site daylight, interior daylight, and the solar gains in winter and summer, you get completely different massings. And so it's important to, from there, try to deduce, okay, so do we want to prioritize daylighting? Is glare going to be an issue? Given the climate and given the heating and cooling loads, is it more beneficial to go with something that's optimal for the winter solar gains or optimal for the summer solar gains to reduce the solar gains? So there are a lot of competing objectives when you're looking at these single aspect metrics. And that's one reason why it's so important to start to investigate these, because there's there's no one correct answer, and it really depends on what you're trying to prioritize. Now, once you've gone through this kind of single aspect simulation exercise, looking at passive strategies, that's when we start to get into whole building energy modeling. And so that really takes us into, as we start SD and DDs, really getting into a comprehensive whole building energy model. And so I'm going to kind of showcase this again in a simple presentation that I did this past year, where I was exploring an automated approach to quality checking energy models against benchmark data and high-level inputs. And the reason why I'm showcasing it in this way is because even from the earliest stages of design, making sure that you're paying attention to your input assumptions and different unknown assumptions, making good assumptions for those, conservative assumptions, really honing in on unregulated loads, those make an impact on what the absolute EUI of your building might be. But the fact is that while you're still in the comparative study arena, all of those EUIs between your baseline and proposed will still be fluctuating, but then the comparisons between the different strategies that you're testing, you want to make sure that those remain have a good amount of efficacy, even in an early design where you don't necessarily have all of the information. And so just looking at this dashboard a little bit, just using rudimentary information about the project. So building characteristics, like the building type, the climate, heating degree days and cooling degree days, we can start to compare those inputs and then those results from this energy model to annual benchmarks, to monthly end use breakdown checks, to hourly end use breakdown checks. And so just looking at, is the EUI in a comfortable range? Do we have simultaneous heating and cooling? Are the peak demands for lighting, equipment, and fans all checking out, the operational profiles? So these are all things that, while they may seem very detailed, by making sure that you are checking in on these things early in design, it just makes it so that then as you're progressing through the design process, you're helping to ensure that the savings that you're projecting, even at the beginning of a project, are then carrying through to your final models, and your final models that you might be using for LEED certification or for code compliance models. And so yeah, that's just kind of the importance of, once you then get into the whole building energy modeling realm, quality assurance for them is going to be very important to improve the long-term efficacy of your models. And so with that, yeah, thank you everyone for listening. And I think I'm gonna hand it over to Dan now.
All right. Hello, everyone. Thanks so much for your attendance, and thanks to Brett and Melissa for those great presentations. So I always like to start my presentation out with a bit of culture. There's a lot of culture involved in a firm-wide approach to something like building performance. And this is a picture of our 3-day staff getaway with family and significant others, and at Ted Flato's ranch in West Texas, where we don't talk about work at all, or you get a lot of peer pressure if somebody stumbles upon you talking about work-related items. So Lake Flato, founded in '84, located in San Antonio and Austin, Texas. We're sort of rounding out the size of firms here, 7,000, what was it, 1,100, and we're 150 people. And we were the firm of the year in 2004, the #1 firm according to Architect Magazine right before the pandemic for their Architect Top 50 list. And I'll just give a quick overview of a few more things related to the firm. We have 5 studios residential, learning, K through 12, higher ed, ecocon, and urban development. We've also earned an industry-leading 14 AIA COAT Top 10 awards. So AIA, American Institute of Architects, and COAT is Committee on the Environment, if you're not aware. And I'm also on the leadership group for the National AIA Committee on the Environment. Lake Flato has been a signatory of the 2030 Challenge since its inception, and we're sharing our numbers relative to the national reported numbers here. I see my slide's a little out of date. The organization of our performance group within the firm is kind of interesting. We have a director, and then in this coordinator area, there's actually 3 people. And then I work very closely with the director of building performance, Heather Holdridge, and our building performance coordinator has a regular monthly meeting with the studio champions. So each studio has a building performance champion, and each project has a sustainability champion. So there's this organized method of disseminating information in both directions. All of our projects start with an integrated design workshop. This is part of the people aspect of deciding what we're going to do and how we're going to do it, so everybody's on the same page at the beginning of the project. This involves as many people as possible, and when we get our way, it's a 2-day effort, but it brings everybody together, the consultants, the key users, sometimes the community, and we discuss what the goals should be. And then we create a document that records all of that. And we use that document to track progress throughout the course of a project. We have pretty defined workflows for both operational and embodied carbon. So you can see here our operational carbon workflow starts with this integrated design workshop, early energy modeling, massing shoebox, some intermediate modeling. The mechanical engineer gets involved at some point for sizing and compliance. And then as often as possible, we try to do post-occupancy evaluation analysis on our projects. Here's the life cycle analysis for, follows a similar path with options for looking at facade, for example, design options, and also whole building. We've had the opportunity to work on and design several mass timber projects, for example. So we'll compare the embodied carbon global warming potential of steel or concrete to mass timber. So I did the embodied carbon analysis on a boutique hotel that we designed that's built now in Austin, Texas. It has a DLT floor and wall system, so dull laminated, no glue in the flooring or the wall systems, so that you can imagine that had a really significant impact. And we were able to analytically understand that using Tally, which is an add-in for Revit. By the way, we also designed the first mass timber building that's being built right now at UPenn in Philadelphia. So the first mass timber building in Philadelphia is being built right now at UPenn. And also, by the way, I'm actually broadcasting from our new office, freshly remodeled. It actually opens on Monday of next week. So I'm here helping with some various setup things, and its goal is well building and ILFI zero carbon. And I don't know how well you can see my webcam, but the desk in this Zoom room that I'm in has a reused material for the desk from the roof rafters of an adjacent one-story building that was deconstructed and turned into a beautiful outdoor plaza area for staff. So I'm going to get into the weeds a little bit on some of the tools we use and actually share a couple of current projects we're working on. So for early energy optimization, we use Autodesk Insight. So it's a Revit workflow that can use massing or Revit building elements. And it basically takes a accurate energy analysis model that properly, if its massing has perimeter and core thermal zoning, as per ASHRAE 90.1 Appendix G. The whole process is ASHRAE 140 validated and gives us some really great opportunities to quickly study passive strategies early on. In this example, you can see the energy analysis model. So the shed roof on the right is a mass element, and everything on the left is a Revit model. And the interesting thing about the energy model creation process is it's really smart in turning roof overhangs into shade surfaces and things that are below the grade into below grade surfaces. And it also has the ability to give us baselines, which is really great. So it automatically calculates the ASHRAE 90.1 2010 baseline. It connects to the Architecture 2030 Zero tool through their API to give us a 2030 benchmark. And then you can see the example here of taking the same geometry and changing the building type from warehouse, healthcare, office to see different EUIs and benchmarks. It's also incredibly accurate if the information is entered properly. I have a blog on my blog BIM chapters on how to create custom wall types within the drop-down list. So anything that is meant to be a wall just gets this one setting. It doesn't matter what the Revit element type is. And by doing that, we worked with one of our MEP consultants in Austin and created this for a current project. We created this white paper showing kind of looking at the point of diminishing returns for insulation. And then we decided to expand it to 5 different climate zones. I have another post that I wrote on the Lake Flato blog comparing Insight and Climate Studio for creating an EUI. And so while I'm very, very much advocate for somebody to use some tool rather than no tool, the AI 2030 by the numbers, which looks back at the previous year on the Architecture 2030 commitment, but that the AI 2030 challenge is what the AI 2030 by the numbers looks back at. And it shows that energy modeling makes a difference, and it also indicates that most firms aren't doing energy modeling by and large. So the ones that are signed up for the commitment and are doing energy modeling are making the bigger difference. So Climate Studio and Insight are actually both very accurate tools, and that's what the blog goes to show. And so as an intermediate, I would argue that most of what architects do is early energy modeling. And once the mechanical engineer gets involved, that's sort of beyond early. We do have something that could be described more as an intermediate workflow where we're using Open Studio and Energy Plus locally. It's a feature built into Revit called Systems Analysis, where you have a very accurate envelope. You can define internal loads, and you can reasonably define the HVAC system. So here's an interesting example in the upper right. You can pick these. I mentioned the custom wall types that we're able to make in a drop-down list rather than actually having to model the walls in a specific way. But then in the lower left, if you want to get more detailed, in the middle, you can see I have a screenshot from one of our passive house projects that's using Woofy Passive. And the same exact wall type can be created in Revit. And you have the ability to enter the thermal conductivity, the specific heat, and the density. And that results in a proper thermal resistance and thermal mass value for the wall assembly. Quick, intentionally overly complicated view here of the internal loads that can be set by the building or by space with things like heating, cooling set points, light power density, occupancy schedules, all that's built into Revit, and it's free. Everything I've talked about till now is actually completely free if you have access to Revit. Here's the look at the assumptions if you're setting up a VRF system with a direct outside air for one part of the building, and another part of the building could be a rooftop unit, for example, so the coefficient of performance for cooling and heating are listed in help, but through Open Studio, you can overwrite that. Here's an example of the energy analysis model with the embedded thermal resistance and thermal mass for an element. And the results then, the checksum reports, for example, can all be viewed in Revit, but it also is looking at an external HTML file. So here's an example of that hotel in Austin where I did the embodied analysis study using Tally on our website, in the investigations page on our website, which is that internal research program that I oversee. You can find this embodied carbon report that talks about this project and the UPenn project and a few other interesting case studies. For daylighting analysis, we use Climate Studio, and this is a current project, middle school that we are designing in New Mexico. Saloma actually posted on their blog this case study of how we, approaching the problem early enough in the project to make meaningful changes to the design and the massing of the building. We were able to get 100% spatial daylight autonomy on this gym, and also make some meaningful design changes on the lower right, 3 examples for a classroom that was being overlit. And then some other tools, we use Woofy and Flixo for thermal bridging analysis, and that's all I had to share. Excited to see what kind of questions we have.
Awesome. Thank you so much, Dan, Brett, and Melissa, for your wonderful presentations. We have a bunch of questions from our audience, and let's begin with the first one. So the first one is, for early design modeling, do you prefer some software over the other? And if you use different softwares for different phases of the project, how do you reconcile with the potential different results? Let's start with Dan.
Let's see, sorry, could you repeat the question?
Yes, so how do you deal with the different results that you might get from different softwares that you use in the different phases of a project?
Sure, good question. So during the same phase, I think Brett alluded to this, the efficacy of the results and making sure that we're not changing something significant in the workflow. So that's the first step, is to just not use different programs. I do like comparing programs, as per that blog post I just shared, that I compare Insight and Climate Studio by very carefully entering the same inputs and making sure that you get the same results. So that's one aspect of it. The other aspect, kind of jumping to the other end of the spectrum, is comparing those numbers with post-occupancy numbers. But then the final thing I'll say is, in between all of that, if you take a look at ASHRAE 90.1 Appendix G, I think it's like the first paragraph that says, this is not meant to be indicative of final real world results. We're comparing passive strategies and trying to make some big moves and studies, and not necessarily trying to figure out what the actual energy bill is going to be, right, for the client.
Yeah, that makes sense. On similar topic, so how do you transition between the performance modeling and the compliance modeling? Sometimes it So lead requires you to model in a certain way, and that might not exactly coincide with the early phase energy analysis where you're trying to get specific answers out of your energy model. So how do you reconcile with that, Melissa?
I think one thing that's really helpful about that to address that problem is working backwards from your compliance model to your early stage model. So as much as you can, thinking about the inputs that you might have to have. If you have defaults, sometimes you might put any kind of generic number in there, but if you really take the time to calculate the appendix G, it's painful the first time, but it saves you a lot later on down the line. And I also think it's helpful, kind of going back to that first question as well, to make sure you're thinking about the early stage model, not as the final answer, and knowing that you're going to get more refined and things might change over time. So often I'll kind of think about the first model in the early stages as a range of results that's going to get more specific as we get more towards compliance.
Brett, do you want to add to that?
Yeah, I think the only other thing that I would add, kind of similar to what Melissa was alluding to with the results being a range of results, making sure that you don't speak in terms of like absolutes at the beginning of a project. So really, yeah, that efficacy of the early design models is really meant to see which strategies are going to have the highest impact and then implement those strategies. And then once you get to your final compliance model, those are going to work out in the end to provide you not necessarily the exact number of savings, but provide the savings as you've modeled them in the beginning.
Okay, what are some of the key questions that need to be addressed in the SD and the DD phase that are often ignored? Brett?
Yeah, I would say the biggest one that we run into would be envelope assumptions. It's very important, especially with a lot of designs wanting to go for that all glass curtain wall design, really understanding what the overall assembly values of your curtain wall is going to look like, and the way that different framing dimensions and types of spandrel that you might be adding, how that really affects your building in a compliance calculation, but then also in terms of what you need to relay to the mechanical engineers for their heating and cooling loads, for the sizing of systems. And so that's, I think, a big coordination step that should happen sooner rather than later. And sometimes I've seen that it happens a little later than it should. So that's something that we definitely push for. That should be a conversation that's had as early as possible.
Absolutely. And somehow it's the norm where we think that, oh, anything related to an envelope should be under the architect's decision making, and anything in the systems is about the mechanical engineer. So, and somehow the energy analyst, the building performance specialist, whatever you call us, they are in a different category altogether, trying to pull everyone together. So how important do you think that architects should have some type of energy training, or trying to teach them some basics? How important do you think that is? Melissa, do you want to take that?
Sure. I mean, it's so important, even if people are not in the weeds doing modeling on all of their projects, just having the fluency and the attention that this is something that's important, knowing how to have the conversations and work through these types of problems. How do you set your goals? All of that, we really need everyone on the project team to be engaged with. And so it's really critical that architects and designers step up to that.
Absolutely. And we learn so much from our projects, and what worked for the project, what didn't work for the project. So Dan, what do you think are some of the effective ways of sharing the analysis and the lessons learned from those analyses with the entire team, with the entire company for that matter?
Sure. And actually, I just want to touch on that last question too, as well, the role the architect should have. So I think all three of us are basically architecture firms. And I think it's just really important because we have these opportunities early on in the design while there's still opportunity, like I mentioned earlier, to make meaningful changes with massing and proportions and self-shading and window to wall ratio, all these passive strategies that we do typically have the most control over before layering on renewables and active strategies. So I think that's really important. And then at Lake Flato, we have a building performance team, but we also highly encourage teams to do the analysis themselves. So they have a shorter feedback loop. And that's where we have those flow charts, and we do training for staff, and just in time training. We'll do it as much and as often as anybody wants. You know, I'm super happy to be able to train staff on how to use Climate Studio to do daylighting analysis, or Tally to do embodied carbon analysis, or Insight to do energy modeling, just on massing. And so sharing that data based on that org chart that I showed you earlier, it was basically an organizational chart of how we disseminate information through studio champions. That's one way, and each studio has their weekly huddles. So we usually try to be at all of those, and not at all of those meetings. We don't always give a report on multiple projects, but we try to share big picture information. And by being a signatory of the AI 2030 challenge, we're obligating ourselves to actually do an energy model on every one of our projects, because it needs to be reported to this data DDX. So it's something that we've, by committing to that, we've obligated ourselves to do energy modeling, and it is possible to do it later, and even sort of once it's in construction documents, just to check that box. But you're not doing yourself any favors by waiting that long.
Do you think that AIA 2030 commitment has changed the way architects look at energy analysis, or do you think they feel like that's just another thing that needs to be done?
Well, I think it's a culture thing. And actually at the National AIA conference this past June, I presented with EHDD and Centerbrook, and the three of us talked specifically about firm culture and how that really needs to be nurtured to properly follow through and do meaningful performance design. And one last thing too is, last year it was released about 4 months ago. I was on a 6-person team commissioned by the AIA, and we wrote the AIA Climate Action Business Playbook. And it's a parallel to the framework for design excellence, in that the framework is about delivering projects, and this is more inward focused on climate action, positive moves in terms of running your business. And a lot of that has to do with leadership and empowering staff and training staff and giving staff resources to do high performance design, and not just have it be a marketing piece, as somebody mentioned and asked in the Q&A.
Yeah, I was just about to get to that. Melissa, do you want to add your 2 cents to the question that since the projects are so fast-paced, how do we ensure that all the studies that we are doing, all the analysis that we do, are indeed a part of this design decision-making?
Yeah, this is a fun question. I think that, I sometimes am a little bit strict when I'm getting requests that's just sort of post validation, telling them, okay, next time you had so many more opportunities, let's explore it a little bit further. So it's okay to push back a little bit, but I think as well, it's really important to build that engagement as early as possible, even before you start the work. And so having a key point person on the design team, someone who's going to work with you throughout the process, who knows it's part of their responsibility on that project, that's a really important part of the integrative design process. And I think it's something that, it's hard to make that work, but it's also really, really important.
That's absolutely right. Brett, I have a question for you. How do you ensure that there is enough QA/QC done during these quick turnout times. And you presented a little something in your presentation about the tool. So do you want to elaborate a little bit more on that? And is the tool just for internal purposes, or is it accessible to the public?
Well, I guess, yeah. So the second part of that question, so the tool is just internal use for us at the moment. So yeah, not open source. But then, yeah, as far as QA, it really varies depending on what the ask is. So I guess first and foremost, I definitely set expectations and manage expectations with project teams. So, you know, if they want a quick turnaround with something, but then we don't think we can turn it around and be comfortable with the results in that amount of time, we make sure that we address that and, you know, set that expectation of this won't take a week, this will take 2 weeks. So it's really kind of being firm with that to make sure that you're meeting the quality that you know you want to meet with your work. But then also it depends on the different types of simulations that you're doing. For a, you know, a final code compliance model or lead model, you want that to be very, you know, locked down, and you want the QA to be there. But then if it's something like a really quick, you know, daylighting study, just comparing some options at the beginning, that's perfectly acceptable for a quick turnaround, because there's less QA that needs to be involved in that. You're really trying to make comparative decisions, so I guess there's less, you know, the stakes are a little lower in that type of situation. So yeah, it depends on what the specific ask is, and managing expectations is very important.
Yes, definitely. That makes so much sense. So we have another question which says, we have found it is not easy to compare options beyond traditional ECMs in energy modeling. What energy modeling program have any of you found that is better at simulating passive strategies? Do you want to start, Dan?
Sure. As I mentioned earlier, we're pretty heavily used Insight or Revit System Studios. And because of the fact that it properly inputs exactly what DOE 2.2 or Energy Plus wants in terms of thermal resistance, thermal mass, proper glazing values. It's a true model-based tool that does perimeter and core thermal zoning. It's actually, you know, the old adage, garbage in, garbage out. if you enter things properly, the results are incredibly accurate in terms of whole building analysis. There are at the earliest level of Insight, the HVAC options are somewhat limited, but again, with that being apples to apples, all the other moves, the percentage difference is incredibly accurate. And then once you get into systems analysis and the ability to use Open Studio, you can do even more. But that's my thoughts on that question.
We are almost at time, but I want to ask one last question, and I want all three of you to answer that, because I'm sure all three of you have faced it. What are some of the challenges faced while implementing this integrated design process? Let's start with Melissa.
I think the biggest challenge, which is a theme that I think we've all talked about, is this idea of directional guidance versus absolute accuracy, that people really want numbers, and they think that what they're going to get from this type of work is numbers. And what we are actually trying to show in this early phase of design is strategies and comparative results, and figuring out, navigating all of these different, many things that you can do. And so changing that expectation, I think, is really important, and something that will be a challenge as, you know, the rest of the world is more and more numbers and numbers and numbers.
Brett?
Well, first, yeah, I completely agree with what Melissa just said. And then I think I'll add to that our integration with project teams can sometimes be a challenge, especially with a lot of us being essentially in-house consultants. Making sure we have the correct scope and fee on a project makes a world of difference in how engaged we can be on a project. And so that's something that we have been doing a better job with, making sure that teams know, what can we provide, what scope can we provide, how long will it take, and then we manage those expectations to successfully get integrated on projects.
Should I answer that as well?
Yes, go ahead.
All right, yeah, I know we're right up at time, but I'll quickly say I've already talked quite a bit about culture, so that's sort of my first answer. But I like to make the analogy of with trying to answer the question of, or show the idea that we should just really integrate this into our practice, like it's just a normal thing that we do. If you compare it to the incredible kind of change in the way firms create visualization. Almost every firm now is using a program Enscape that just makes your Revit, SketchUp, Rhino models look amazing without having to do any work. That used to almost always be a really big extra add to a project. And while we still might do it if there's a special video like an animation or still images that are going to show up in the media, we're just doing it because it benefits the design process, and doing this performance analysis benefits the design process, it benefits the client, it benefits the environment. So it just the kind of the thinking around it needs to sort of shift culturally to it just being part of the workflow. And of course, we all need to, have the time and the budget to do these things, but it just needs to be built in and not something that's an afterthought or a barrier to actually implementing it.
Absolutely. And with that, I want to say thank you so much, all three of you. This has been a wonderful conversation with you all. And I thoroughly enjoyed talking to you about this topic. So thank you so much. And thank you for the attendees who attended and asked questions. I hope you all took something back from this. And that's all. Thank you.
Great, thank you very much.